batsman, bowling, fielding, all-rounder is important. In the same way here also, we should be thorough with the functional domain knowledge, mathematics, computer science required to be an expert in data science or data analyst. Here, we are using this buzzword, latest word, analytics. Before this analytics buzzword also, concept is there in the term of analysis. Just like old wine in new bottle, old concept in new term. Here, data analysis is there. Statistical analysis is there. So, analysis means just understand the data. Based on our understandings, we are trying to interpret the results and trying to take some decisions based on that. In the same way here also, analytics is also process of inspecting, cleaning, understanding, everything. Not only understanding, adding the automation process of analysis, we call it as analytics. So you observe in while teaching C programming, file systems, while moving from file systems to the database systems, how you are going to work out, how you are going to do examples. If you work with the file systems also, you can develop applications. If you work with the file systems, importance is for any change, expertise is required. In the same way here also, you are applying data analysis and statistical analysis. Whatever the result you are going to get, to understand that result, statistical expertise is required. You observe, data mining process is there. After applying data mining process or some k-fold series or standard deviation, you are going to get some result. To understand that result, statistical expertise is required. But analytics point of view, what we need, analytics should automate the entire process. At the end, result is a yes or no. A Navi user also able to take decisions like whether I can invest on so and so particular share. For that question, if you go 3 pages, 4 pages information, last year increased, last 2 months back decreased, again increased. All this stuff not required for a customer. Customer question is, or your CEO or top level people question is, yes or no answer only. Whether can I invest or not? Reasons, what happened previously, all this, your work, your headache. So, analytics refers to able to work, able to give solutions to the Navi users, customers, automating the decision-making process, So, with reference to data analysis or mining point of view also, analytics include both data analysis and communication, guide to decision making. You observe data warehousing, data mining, data analytics, so big data analytics, so data science. These are all familiar words to say sequence of databases, data related only. So data analytics refers to, it's a visualization part, gives automation, easy to interpret the results, immediate take to decision making. So it acts like an extra brain, extra eye, extra ear, extra sensor, like a sixth sense to an organization. So you observe data. Data refers to actual facts. Data, our computer terminology point of view, it may be numeric data type, character, real, discrete, continuous. In this way, statistical terminology, discrete, continuous, so binary, interval variable, scaled, ordinal, rational, categorical. That means whenever you move from computer science to the data science or data analytics part, you are going to add statistical terminology, statistical words, even for data representations, data also. In computer science terminology, data we are going to store in structured tables. There we call it as data set. In computer science terminology, field, row, column, this type of terminology we are going to use. Whenever you enter into the statistical part or data analytics or data science part, terminology going to be changed. Observations, data set, sample, universal data, this type of things we are going to see. Here data, it may be univariate in the sense single column, bivariate, multi variables, two variables, bivariate, two variable data, table with two columns, multivariate, several columns. So data is available in structured table format. Recent data trends like RFID data. If you visit any shop or any market, any supermarket, any places, so you can find RFID sensors, web term data, sensor array data, gene expression data, consumer preference data, symbols, social media data, even sometimes like dislike symbols, angry symbols. So even while using social media, thumb symbol, uh, uh, comfortable, not comfortable, angry symbols, dislike symbols. These are all important while taking the feedback while working out for any specific task. Here we are talking about the structured data. Unstructured data again we'll see. First, we are in the terms of structured data. Structured data you can represent in. Is it okay? Am I audible and PPT is visible? Is it clear?
Yes, sir. Audible PPT is also visible, sir.
Okay. It's data may be either one-dimensional, two-dimensional, multi-dimensional. You can represent as a array, list, table, matrix, vector, data frame. This terminology you observe. Array, table, common terminology. List extra added. Matrix also common term. Vector, data frames. You observe these new terms. Suppose you observe table is available, city, time, total revenue. So this table consists three columns with several attributes, with several rows, several observations, several records. The same table we can visualize. You observe a more number of rows converted into row column headers. Previously only column headers are there. Now you converted this column headers into row header and column header. So by going through this, visibility is increased, able to understand quickly when compared to the previous version. Table data is there. Now we are trying to visualize the data very easy, moving towards easy understanding. So observe, while converting from this table to the one side, one column header to the column headers to the row and column headers point of view, again normalization plays important role. Which column I need to choose as a row header, which column I need to choose as a row column header, which column I need to choose as a cell value. This matters a lot. Again, mathematical theorems, normalization plays important role. Wherever unique values are available or repeated values are available, based on that we can decide row header, column header. You can go like this. If it is 4 column, 5 column, If it is 4 column, how can we see? If it is a 4 column, we can convert into cube. Property, city, time, total revenue. We can convert into a cube. So by using cube also, we can understand easily. Even in data cube construction, one option is there at the end, row wise summary, column wise summary, multi-dimensional. It's like a multi-dimensional operations like slicing, dicing, pivot, drill down, roll up, drill down. This type of operations we can do easily with multi-dimensional. So in this way, facilities are there for easy understanding if use voluminous data is available. In the same way, for the same table, if we apply visualization part, the same if you represent with a pie chart form or bar chart form or any graph format, more easily you can understand. That means we are trying to understand easily, to represent the data easy. Here, I think now you understand the meaning of analytics. Analytics it refers to. So this is the these are the types of analytics proposed by the Gartner. Who is Gartner? Any one of you, please. Gartner. Who is Gartner? Any one of you? Any one of you, please, participants. Because we are living in teaching field, we should know Gartner. Gartner is a market researcher, developer, entrepreneur. Is going to create Gartner hype cycles. Whatever he creates Gartner hype cycles, that most of the times 80 to 95% working correctly. So most of the researchers propose, most of the researchers refer Gartner hype cycle. So even for your any subject, it may be cloud computing, AI, artificial intelligence, or chat GPT, LLM, any subject point of view, you check with the Gartner hype cycle. You can get something related to that. Whether it is live, existing, or that life is maybe 10 years old, next 10 years only, or 5 years only. That information you can find because changes are occurring frequently. Whatever the subject we are going to learn, is it worthwhile for at least next 5 years or next 10 years? Or if it is, if you learn something and if it is vanished within next 2 years, it's waste. So we need to select the subject which should be useful at least next 10 years or at least 5 years. That we need to choose. Okay. Here, types of analytics. Here, analytics point of view, types of analysis, descriptive analysis, predictive analysis. As per statistical terminology, you can find two types of analysis that we call it as descriptive analysis, predictive analysis. But when coming to the analytics part, you can find descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics. Here, descriptive in the sense describing, understanding what happened, just simply understanding, exploring. Diagnostic analytics, why did it happen? What is the root cause to work out this? What is the root cause behind to happen like this? So in statistical terminology, before this diagnostic analytics, this analytics terminology, they have one important topic that we call it as root cause analysis. Root cause analysis also one is there. That is the part of descriptive predictive analysis, descriptive analysis, predictive analysis only. So the same diagnostic analytics, predictive analytics, what will happen, forecasting, estimation, future predictions. The another term we call it as prescriptive analytics. How can we make it happen? If you are able to identify the root cause to happen particular that, based on that we can make it happen. Prescriptive analytics, it's like a doctor prescription. You need to work out do or die type. At any cost, we need to complete the task within the winning strategies. Winning strategies. So apart from these four, you can find one more in recent technical papers. One more analytics is there. What is that? Any one of you, do you know? Apart from these four analytics, fifth one is there. Anyone, do you know? 5 types of analytics: descriptive, diagnostic, predictive, prescriptive, 2D, 2P, 1C is there next. Starts with C. Anyone?
Quantitative.
That we
Chatbot.
cognitive analytics.
Yes, sir. Yes.
So, and next option is a cognitive analytics, sentiment, playing with the brain. So to perform analytics, what type of parameters we need to consider? You observe data set. We got one data, one table with 10 columns or 20 columns or 100 columns. What are most important features? How to identify feature attributes? So to here analytics, data scientist, data analyst, business analyst, whatever the role, their small differences are there, but concept is common to work out, to analyze. While analyzing, they need to take feature attributes, important attributes. So to identify the important attributes, we need to understand the first thing is this data set, what purpose we are using, what is our aim, what is our goal, is it related to the most objective mission objective, that means organization point of view you are looking, or you are looking individual perspective or a department perspective, or it is related to the political economical perspective. So how you are looking, that is most important. Based on that, you can identify the feature attributes. First thing is you need to understand your problem statement, what their requirements, client requirements. Based on client requirements, you need to identify the feature attributes. For the feature, they given general information. If it is most organization point of view, one technique you need to follow. If it is political, economical, one technique you need to follow. If it is individual strengths, weaknesses, opportunities, threats, you need to follow. If it is one particular recommendation system or in this point of view, customers, actors, in this way, you need to follow these basic guidelines to identify the feature attributes. Because analytics point of view, identifying the feature attributes plays important role. Here, till now, different types of analytics we discussed. Apart from this, you can find A to Z analytics, big data analytics, cloud analytics, IoT analytics, business analytics, outsourced data analytics, smart analytics. That means these related to their technology point of view, concept point of view, model point of view. Here, based on the data, mobile data, web data, movie analytics, movie data, social media data, in-memory analytics, cognitive analytics, self-analytics. Present day self-analytics plays an important role. We need to know ourselves first. What are our strengths? What are our weaknesses? How to live a happy life? Information detection, web search, web analytics, Google analytics, computational biology, finance. In this, several options are there. You can use analytics in our day-to-day college life also. College administration point of view, college, our education field, college point of view, we can do analytics. Can you give some examples related to the college analytics? Any one of you, please? College point of view. Analytics on student opinion poll. Here, analytics in the sense summary. You need to analyze.
In chat box, one of the participants mentioned results, sir. Result.
Yeah. Okay.
I sincerely request participants, please respond wherever sir is asked, please.
So, in education institution, analytics on student opinion poll, exit poll, percentages, that means results, even comparison between rural and city background, local and non-local, gender-wise, caste-wise, placement-wise, higher studies-wise. In this case, several options are there for summarizing. Here, suppose if we want to work on one case study, you taken some student analysis, you created student data, you applied some model, you got the result, and you are submitting that case study. Is it acceptable? Is it worthwhile for a main project, BTech student main project, or a MTech student main project, or a faculty point of view? Applying one model on particular data set after getting the result, observations, writing observations for a paper point of view, is it acceptable? Technical paper point of view or research paper point of view, is it acceptable? So generally this type of questions we are going to get. So to make worthy, you take any data set. It may be telecom churn analytics, or movie recommendation systems, or fraud analytics, or social media data, or stock market data, or weather forecasting data, or agricultural farming data, any data. You try to work with multiple models, suitable multiple models. All models may not be applicable. We'll see which model is suitable for what type of data. That also we'll see. So I have taken Bitcoin data set based on the data available, and if required, converting numerical data to the binary data or binary data to the factors point of view also with the conversion. So we can apply for some models. So at least 3 to 4 methods you need to apply on the data set and prepare a comparative analysis that we can submit as a mini project or main project or internship or a paper point of view. Then it will be acceptable. simply taking one data set, exploring some few statistical functions, applying single model and interpreting data and submitting is not, may not be acceptable. So even for even BTech main project point of view also, at least 3 to 4 different models need to apply. So this is my suggestion related to the project or application or research paper submission point of view. I think this we can find in our data mining concept. You observe shallow data, discover with SQL, discover with SQL. That means simply querying, multidimensional overlap, online analytical processing, next level. Next level, hidden data, KDD, knowledge discovery in databases. Still you go in deeper, deep data, deep learning, machine learning, just to understand the intensity of data. Here, you take any data, within the data itself, you can find some relationships. That we need to identify the relationships. How to identify the internal relationships within the data? Correlation, covariance, cofactors, independent variables, dependent variables. Even in our database terminology, you can use the term called as functional dependency. Discusses about dependency within the attributes within a table. In the same way here also. In a table, whatever the data set is available, within the data set itself, you can find some hidden data. That identifying that hidden data and exploring that is a technique. That is the intelligence. View of data. How can we see the data? Data set is available. It may be CSV format, comma separated value format, or a table format, or maybe unstructured data as a different pages information, or a JSON format, semi-structured data form. That means XML format. So data may be any form. That data, how you are going to visualize, how you are going to see. That is, viewing of data is most important. Our perceptions are most important. Here you observe, you can find one idol. Immediately after going through, after seeing this idol, what you got in your mind? One person may see Lord Venkateshwara. One person may see Narsimha. One person may see Kurma Avtara. How they are going to identify this is Venkateshwara or Kurma Avtara or Narsimha in a sense, based on the previous knowledge. That means from known to unknown we are traveling. Whatever the thoughts, whatever the internal appearance, internally, whatever is available in your mind, with that you are pursuing, with that you are seeing. As per your internal observations, you are able to see. In the same way, here also data is available. It may be scientific data or molecular data or weather data or spatial data. For those, you don't have any internal knowledge. In this example, you got some internal, you got some molecular data or scientific data. On that scientific data, how you are going to see, how you are going to work out. So here research refers to, you need to see the data like a bird's eye view. From long distance, maybe 5 kilometers, 3 kilometers high from that sky, bird able to see a minute particle of food item. In the same way, we need to see the data several times. We need to go through the entire data. Is there any mappings? Is there any dependencies? Is it all individual? Is there any correlations from one to another? Different angles, different perspectives you need to see. Then only you can understand, you can get some basic idea. Not only seeing, you need to apply the statistical functions and observe the results if required. Here, to know more, to enhance our knowledge, to get entire, you need to go through Prashnopanishad, questionnaire. You need to first you identify, you list out the questions from the data set or from anything, not only data set, anywhere, anything. If you want to enlighten yourself, you need to make self questions. So that prepare a questionnaire. For that questionnaire, you try to get the solutions and enlighten yourself. So we are living in data-centric, data engineering world. So to be a perfect in data analytics, you should be thorough with the data engineering. Data engineering refers to different concepts like data modeling, database, storage management, data pipelines, data infrastructures, monitoring infrastructures, data lake, data containers, virtual data, cloud data storage representations is also most important. So anyway, our subject is related to the data analytics part. That's why I didn't added much related to the analytic data engineering. If we want to be thorough with the data analytics, data science point of view, we should be aware of storage representations, cloud usage, data lake usage, data containers part also. So these related to the basic introduction related to the data analytics part. Now coming to the project life cycle. If you want to build one case study, how to build a case study, what are the important steps for building a data analytics project or a machine learning project or a data science project. You observe, you may get a question like, these steps are common for a data analytics project, machine learning project, data science project. Most of the cases, these steps are similar. Anyway, for data analytics point of view, these 5 steps are most important. 5 steps. OSEM model, OSEMN, OSEM model, obtain data. Here, these steps regarding project development life cycle, you may find different terminology in different textbooks, but overall concept is common. Somewhere you can find 7 steps, somewhere you can find 5 steps, somewhere you can find 8 steps. but overall the entire process is common, whatever the textbook you say. Obtain data, that means data collection. Another textbooks you may find it as data collection. Scrub data, data cleaning, data pre-processing, explore data, data description, exploratory data analysis, EDA, descriptive analysis, model the data, interpreting the data. So these 5 steps are common for any project. I request you all concentrate on this. Even by reading the textbooks, by going through the papers also, you may not find this much information. This will be useful for you still if you are in data science related, data analytics related, definitely 100%. Here, obtain data, data collection, source identification, all this comes under obtain data. Scrubbing data, data cleaning, explore data, descriptive statistics, model the data, identify the suitable models, identify the suitable models. That means different types of models are there. It may be classification, clustering, supervised learning, unsupervised learning, frequent pattern mining, associations. In this way, different types of models are there. Interpreting the data, whatever the results you are going to get, that results, how you are going to perceive the results, how you are going to use for decision making. Here, obtain data collection point of view, you can apply querying from database, flat files, Excel data, even in R environment also. Just I will start R programming. I'll show you. I think you are clear with R Studio, R programming environment. You can find in R also one option is there, data connections. Connections, new connection. Just like ODBC, JDBC, Open Database Connectivity, Java Database Connectivity, you can connect this R environment with Reckl's database or MySQL database or Excel. From that also you can extract, but you need to convert into the CSV format or environment usage format. You observe, the important thing is you can collect data from different places in different formats, but you need to convert into the structured form. Then only R can useful for to perform analysis. That is important thing. R required CSV format or structured format. If it is unstructured data, you need to go for NoSQL, MongoDB. If it is social media data, Facebook, WhatsApp, Twitter data also you can collect. That also you can use for your analysis. You can find a Twitter analysis also. Website data, web scraping, beautiful soap. This also you can apply. That means you can integrate with the APIs, Amazon Web Services. That also you can use. Tools are there. Here you can find add-ons. And one more thing, shiny web app, shiny web application. That means you can develop a web application with background support as a R programming. Front end utilization, visualization part, shiny web application, you can integrate this. Or you can download the data sets from Kaggle, KD Nuggets, ISRO, NRSC, Bhuvan. Even you can download regional language data also. Telugu text, on the Telugu text also you can perform some analysis, text analysis. So for data collection, you can use sensors. You can add sensors in your room, temperature, humidity, lighting. So different sensors are there, IoT sensors. By applying these IoT sensors also, you can collect data. By applying this Wi-Fi signals, Bluetooth, by these things also you can use. Different types of sensors are there. Alcohol sensor, ultrasonic sensor, IR optical sensor, LDR sensor, gas sensor, gyroscope sensors. These sensors are also available. These sensors are also useful for data preparation, data collection. So in this way, you try to collect the data on your own, or you can download, or you can prepare a questionnaire, collect the data from different places through Google Forms or manually, whatever way you prepare one data set. That is first step. Once you prepare the data, there is a possibility of getting some missing data or irrelevant data. Fine tuning is required. So for that fine tuning point of view, scrubbing data or data cleaning, scrubbing data cleaning, because if we give worthy data, we are going to get qualitative results. Qualitative data, if you give qualitative data, quality results. If you give garbage data, you are going to get garbage out. So data scrubbing, data cleaning point of data consolidation, data cleaning, handling missing values, outliers, so dimensionality reduction, smoothing, normalization. These are different options. Distance measures. Suppose distance, some places you can measure distance in kilometers, some places in miles. You need to consolidate. Rupees amount. Some places in India, rupees, another place maybe euro, another place maybe dollars. You need to consolidate. Your data is not related to one specific region, not only Telangana state. Your data may be related to entire world. If it is data point of view, sometimes text cleaning techniques. You got some text from Twitter. On the Twitter data, you need to do some analysis. In that case, removal of stop words, removing URLs, emojis, text cleaning techniques. Image pre-processing. Sometimes you got images. On that image analytics, noise removal, image filtering, video analytics. Input is video. On that video, you are trying to perform some analytics part. It may be emotions, where a high romance is there, where vulgarity is there, where sense of humor is there. If you want to eliminate some of the things, if you want to identify only particular things, in this way, you can do some video analytics. Simple. You taught a subject that recorded without listening that, I need to identify, I need to filter that this faculty is very good in teaching. I got 100 profiles, 100 candidates videos are there. Each and every candidate 5 minutes video are there. So from these 100 candidates, I need to filter, I need to extract only 10. How I need to choose? I don't have time to listen all these 100. So you can give some parameters like tone, specific subject. And this is some parameters. Video analytics. Here, handling missing data itself is a one PhD topic. How to handle missing data. Here data is available. This data we are using for analysis purpose, means statistical analysis purpose. Is it important? If one row missing, what will be happen in summary? In summary, in the sense either mean average you are going to take or total you are going to take. So in that case, you can delete it. Simply ignore the tuple. Are important. Then go for imputation. If it is a time series problem, one way. If it is general problem, one way. In this way, different options are there. I'm not going in depth related to the these missing values because of time constraint. Simple example I'll give you. Employee data. One of the employee salary is missing. In that salary column, how we need to fill it? One option is average of all employees. Is the one option for filling that particular employee salary. This is first option. Second option, employee corresponding designation I'm choosing. Based on the designation, I'm taking the average of all concerned designated employee, concerned job holder, same designation employees only I'm considering mean of that. That is second option. Third option, I'm considering age, that means experience plus job corresponding to job and experience based mean value adding as a salary. Within these three options, which one is best? Which one is best, ma? So first option is mean, all employees. Second option is a concerned job only. Third option is a concerned job plus experience also considered. So third option is best. So in this way, you can apply some strategy and find the missing value. So this is about data cleaning, explore data, data exploration. So we need to understand the data. To understand the data, we can apply some statistical functions. Statistical functions like summary, mean, median, mode, standard deviation, variance, correlation, covariance, cofactors. In this way, we can apply some statistical functions to understand the data, test the data. Here, first thing, types of data, discrete data, continuous data. Discrete in the sense nominal or ordinal. Continuous if it is interval ratio. If it is interval ratio, mean is applicable. If it is a discrete nominal or ordinal, either mode or median applicable. So in real life, data may be in the form of categorical, ordinal, interval, ratio data. Why we are giving importance to the business analytics? Data analytics is there. This analytics generally most of the times we are going to use for business purpose. business analytics. Because in business, more number of actors involved. When analytics is required, if it is simply two employees, supplier, customer, two persons, business, there is no business involved, only two members involved. There is no complex transactions. In that, analytics is not required. If it is 3 or 4 suppliers, customers, owners, employees, 4 actors involved, there may be some transactions, so some discussion is required. But business intelligence point of view, more number of actors involved. You observe suppliers, customers, owners, employees, competitors, government, environment. Present, we are living in next generation business intelligence analytics world. You can find online communities, news, media, international partners, multinational companies, social media. So wherever more actors, more number of people involved, their analytics required. So in business analytics, so pricing point of view, to increase their business, to increase their share price, we are going to use this analytics part. To sustain in the market, here you observe data. This is table. In this table, what are categorical data, what are nominal data, what are ratio data, supplier, order number, item number, these are all categorical values. If it is numerical terms, ratio is there. If it is a time duration is there, interval data. So you need to understand categorical, simple, numerical, ratio, duration, time is there, interval. If any sequence is there within that ordered data. So here variables, quality of life is there. One variable, ethnicity, another variable, race, another variable, diabetes, another variable, systolic BP, another variable, values also given. So now you try to identify quality of life comes under which attribute, which data type. Any one of you, please, ma. Please respond. Am I audible? Is it okay?
Yes, sir, you are audible. Participants, please respond. Yes, sir.
Quality of life comes under which attribute, which data type? So quality of life, ordinal data type. Some order is there. Ethnicity nominal, race nominal, diabetes nominal, systolic BP range is there. So it's we call it as continuous. So in this way, data types, attributes and data type is important. Why data type is important? In the sense, based on the data type available, you can choose the model. If you want to choose the one particular model, immediately question is what type of data is available. So model the data, explore the data is the describing the data. So while describing data, you are going to understand what is the data summary and its summary and its data types. You are going to understand. Model the data based on the inputs. So based on the data available, you need to choose the model. For choosing the model, you need to understand the problem statement. What are the client requirement? What is your output? What is your expected output? That means your inputs you got. At the same time, what you are expecting from client point of view or problem statement point of view. So based on that output, you can choose the model. Based on the output, you can choose the model. So that model identification is most important. For modeling, model selection is important. For model selection, whether it is working properly or not, when you identified a model, that model is working properly or not, how to test it. So the same data, original data, you divide into training data and testing data. On training data, you apply model, you build that model, you test the result. Once you got the result, you test the same data with the test data set and confirm yourself and verify yourself working, is it's working properly. So model data point of view, choosing the model, and also whether it is model is working properly or not. For that training, you divide the original data into the training data and testing data. On training data, you build, you experiment it. Once you satisfied with the results of training data results on that particular model, the same model you apply for test data and verify the results whether expected you got or not it. Then you can go for real. So once you identify the model, for prediction point of view, if you apply predictive model, that predictive model always uncertainty and risk is there. For prediction model, predictive models point of view, uncertainty and risk is there. This slide and the next slide, these two most important. After going through the experts, after discussion with experts, we prepared this. Different types of machine learning models are available. Supervised learning models, unsupervised learning models, semi-supervised learning models. So when we can apply supervised learning, when we can apply unsupervised learning. If it is a continuous target variable, you can go for regression. Supervised learning, continuous target variable is available, you can go for supervised learning. In that supervised learning also, regression you can go. If it is a categorical target variable, classification. Categorical target variable classification. I think you understand the meaning of a category, continuous variable, categorical variable. Continuous variable, suppose age is increasing, weight also increasing, height also increasing. Continuous variables, age, height, age, weight. Categorical variable, unsupervised learning. In this unsupervised learning, target variable is not available. There is no class label. There is no target variable. In that case, you can go for clustering or association. Clustering or association. Categorical target variable available in semi-supervised learning. Go for either classification or clustering. Classification or clustering. This basic minimum data is important. Minimum knowledge is important while working with data analytics or machine learning. Interview point of view, job point of view, or college lecturer interview point of, faculty interview point of view. Also, these type of things more. You observe when we can use logistic regression, when we can use linear regression. That means if response variable is continuous and predictor variable is continuous, then go for linear regression, neural network, k nearest neighbor. Response variable is continuous and predictor variable is categorical, then go for linear regression, neural network. KNN not suitable. Response variable is categorical, predictor variable neural network. If no response variable, cluster analysis, principal PC component analysis, association. Decision trees, if response variable is categorical and the predictor variable is also categorical, then go for decision trees, Navy base. So prediction techniques, different types of prediction techniques are available. Regression, what is regression? What is linear regression? What is multilinear regression? What is logistic regression? What is auto regression? What are auto-regressive inductive models? What is AR? What is ARI? What is ARIMA? Regression, just it shows the relationship between dependent variable and independent variable. Mathematical point of view, just a simple slope intercept form y is equal to mx plus c. If you go in depth, exponential form. If it is two variables, one way. If it is multiple variables involved, like age, weight, age, height, regression. Another example, person able to purchase a system or not, their income increasing or decreasing. In that case, multiple variables involved. Go for multilinear regression, logistic regression, auto regression. If data is moving, whatever regression we applied all these on static data, dynamic data, stock market data, continuously moving, time series data. If it is dynamic data, in that case, you required some other models, dynamic models, auto regression models, auto regressive moving average models. In this way, auto regression moving average models, ARMA, auto regression integrative moving average models, Holt-Winter model, fuzzy logic model, neural network, genetic algorithm, loss of least absolute shrinkage and selection operator. In this way, different models are there. Now, learning models, even you can go for deep learning models also, depending on your requirement. Artificial neural networks, CNN convolution neural networks, recurrent neural networks, deep learning also you can apply. So machine learning models, you are going to get the result. That result, interpreting the data is end user, customer point of view. So actionable insight is a key outcome from a data science project. So that result you need to specify in visualization part for easy understanding. Visualization part for easy understanding. So in R programming visualization point of view, you can use ggplot. In Python, you can use matplotlib, ggplotlib, seaborn, or you can use Google Colab. Any. So these are the steps involved in building a data analytics project. OPSEM, obtain data, OSEM model, obtain data, scrubbing data, explore data, model the data, interpret the data. So example works for your understanding point of view. Forecasting on dollar rate, forecasting on ionospheric data, weather forecasting, social media analytics, Twitter analytics using our app subscription analytics, air pollution analysis, water quality analysis, COVID data analysis, predicting stock market price, chain chain of mails analytics. So technologies, not only analytics you required for a real life project, you should be thorough with IoT sensors for data collection, cloud or virtual environment or data lake or data container, basic knowledge for data storage point of view, data prediction point of view, machine learning. Data prediction point of view, machine learning is important. You should be an all-rounder to get the job student point of view. Here you observe the technology involved. You can find sources, different formats, different formats. I think you studied data warehousing, ETL process, extract, transform, and load. Multiple sources are there. Even though multiple sources, you need to extract and transform and convert into single constant format and store in the data warehouse. From the data warehouse, extracting the data by the end users, data miners, report generators, developers. In the same way, data may be in different form, multiple formats. You extract the data, you apply data extraction, restructuring, filtering, integrating, transforming, entity. Once you extract, store into one place. From that, you apply analytics part, analytical engine. After applying analytics also, you can build OLAP structures, MOLAP structures, cube structures, visualization. Even after getting the analytics part, for that also again you can apply some third-party tools like visualization tools, dashboard applications. So that can be used by the end users. So here R is a software. Statistical tool, or is a statistical tool started with the analysis purpose. R as a R is a open source tool, open source community. Because of their community developers, based on the requirements, they added packages, they added new functionalities. Now R has the capability of supporting backend process also, data collection process also, programming part also, server client relationship also provides. So R started with the analysis. Now R has the capability of supporting backend also. In the same way, Python started with programming support. Python started with backend support. Going through the working out with several projects, Python has the capability of adding new packages. Now Python has the capable of visualization, front end part also. So if you see the evolution or development, Python started with the backend and support for front end also. R started with the front end support. Now R is able to support for backend process also. This is evolution of Python and evolution of R in terms of analytics part. But as per the latest present industry requirement point of view, this we need to understand. Now you can find edge computing, fog computing, data lake, data containers, huge voluminous data we are generating, data sources, CRMs, HRMs, databases, flat files, competitive markets, internet, ERPs, IoT sensor data. For this, we can use ETL process. You can use like Informatica data warehousing tool or Talent. This Talent is open source. Hello, are you able to see this?
Yes, sir. Yes, sir. Last 2 minutes back signals problem. Now okay.
It's okay.
Okay.
Talent is a data warehouse free tool for academic point of view. For experimenting, for demonstration point of view, you can use a Talent tool. Talend, open source tool. Talent has the capability of interacting with AWS, Amazon Web Services, Cloudera, Big Data supportive, Spark supportive, and so data mods, data lakes. Now, technology point of view, streaming data, cloud data warehouse, Redshift, Snowflake schema, APIs. So with this edge computing, now using Power BI tools. So front end part, different third party tools are came into existence. That Tableau or Power BI, these also at least somewhat we should be thorough basics. So another example, a credit card company receives thousands of applications for new cards. Each application contains information about some data. Problem: to decide whether an application should approved or to classify applications into two categories, approved or not approved. Credit card applications you got, whether we need to use the credit card, not to use the credit card. So for this, we need to develop an application. In this way, build several case studies, give this problem to the students. Automatically, students will work out and student give some solution. From the students, we are also going to learn something. So this is also an example. Supervised learning, unsupervised learning. Summarization, email data, chain of emails continuously you are getting. Suppose if you are working for a particular project or for a particular community, you can see 50 mails, 100 mails. So instead of going through the each and every mail, summary we required. That summarization of mails. So for text summarization, some steps. We're not going in detail. Identifying leakages in long pipeline, petrol pipeline, gas pipelines are there. So in this way, we need to work out related to the analytics part. R programming is most important for analytics learning point of view. For research point of view, for student point of view, Python is best. If a computer science student or IT student prefer Python is suitable. preferably Python is best. For non-computer background, like civil, mechanical, those people, they are in business, MBA people, if they are interested to learn data analytics, so for those people, R programming is suggestible. So my suggestion is for non-computers, R programming. For computer science students, Python is best. As a faculty, as a teacher, we should be thorough with both Python as well as R programming, or at least any one. So overall, the purpose of life is awakening within you and awakening the others. Lifelong loyal love for learning. For student point of view, because now you observe change happened. Change happened in the education system. Change happened in students' perspective, management perspective, student point of view. Instant, they required instant food, immediate result. Education AICT point of also NEP, National Education Policy, not only outcome based. Teaching strategies, different teaching strategies, case studies. So you can give case studies to the students, like business models. We are facing may not be up, expect jobs also not coming. So we need to jobs are also expect students who need to be the entrepreneurship, to be the entrepreneurship business models. Alibaba business model, Tesla business model, different business models are there. So give one case study to 3 or 4 people, one group, ask them to invest time on that, to go through that and prepare one report. We need to give continuous work to the students. So these are the basic points from my end. Any questions?
Participants, I sincerely requesting any questions is there? Deepka madam, any questions?
So just 2 minutes time. I will take 2 more minutes. Just to observe, already table, some code is available. Data. Here, this is our environment. I think you know the concept of R programming, R studio, about R process. So you can find 4 windows in our R studio. First window for R code, second window for console, third window for environment, fourth window for packages, plots, graphical view. So here data refers to, just to observe, what are the data sets available in our environment. These are the data sets. Even you observe, if you see the Veka data mining tool, Veka is one of the data mining tool. In that, whatever data sets are available, all predefined built-in data sets of Veka is also available in R. So I have taken one data set, empty cards. This empty cards is the data set.
Sir,
Empty.
sir. One chart box, one question received, sir. Ask expert from same case studies and Nadu. They will ask same case studies.
1 second, sir. I will go through this case.
ఇంకొకరు ఎవరో చాట్ బాట్ లో ఈసారి బిల్ట్ ఇన్ డేటా సెట్ ఇన్ ఆర్ అని అడుగుతున్నారు.
Yes, several data sets are available. Whatever I shown, all these built-in data sets. You observe. These are all data sets from R. 8 passengers are able to see this.
Yes, sir. Yes, sir.
8 passengers, BJ sales, BOD, stock market, formaldehyde. These are all data sets available in R Studio, R software itself. Iris data set. So these are all predefined data sets. You can extract data from other places also. For this simple one command, I'll show you. Read data. This is core data. So empty cards is one data. This empty cards data, I move to the car data because I'm not modifying the existing data. So this existing data set assigned to the car data, named as car data. Now car data is the name of view of car data. This is run command. Now you observe, this is car data. You can find environment, you observe. Car data, 32 observations, 11 variables. That means 11 columns, 32 records. So we are not able to see the entire data. So we are trying to see the first 10 rows, head of car data, 10. Tail of car data, last 6 rows. By default, 6 rows only. STR, structure of data. This is the structure of data. Data frame, 32 observations, 11 variables. MPG, miles per gallons, numeric data type. Display, numeric data type. In this way, able to histogram, you observe. Box plot analysis. So this box plot, based on this analysis, we can understand this starting this box minimum value, maximum value, minimum first quadrant data, median, third quadrant data, maximum value. In this way, box gives information. So density, how the data started in MPG variable, summary of car data. Summary refers to, you observe, for each and every column, minimum first quadrant to median, mean third quadrant to maximum. So this car data, you can find AM. Okay. This is, you observe this AM transmission, 0 is equal to automatic, 1 is equal to manual. auto manual cars. So we can divide this data set into the two subsets. One auto cars, another one is manual cars. So this next we apply t-test correlation in this way. Simply due to time constraint, t-test. After applying t-test, we got some result. Alternative hypothesis true, difference in means is not equal to 0. Correlation, applying correlation. Applying regression function, linear modeling regression. Test data. From the test data, we are trying to predict car data. So this is the possibility. Next possibility. Values. So in this way, you can use for regression purpose. Same way you can apply Twitter analytics, so YouTube analytics, so mobile WhatsApp data analytics, so a chain of email analytics, so fraud data analytics. So in this way you can choose. So these are the points from my end. Any questions? Any questions, please?
Sir, these are built in the data set in R. Please let me show how to move that to part to that part.
Here I already shown you.
Yeah, no problem. Oh yes, done.
These are the data sets. So command is you observe the command.
They asked you, sir. No problem, sir. Already done. Okay. In other participants,
This data open brace close brace is the command to see the data sets.
Participants, any queries? Okay,
any
sir.
other questions?
Okay, sir. Thank you. Some of the participants are sir, which is user friendly, Python or R?
User friendly, yeah, based on this concept point of user friendly characteristic point of view, R is user friendly. User in the sense customer, programmer, developer. In that case, R is best.
For research purpose, they asked you to some of the query.
Research point of view, I prefer Python.
Any other queries? Okay, sir.
Google Colab or Python is more same. You are using the environment. Environment is Google Colab. Python, Google Colab, these are all common.
Okay, sir. Okay, sir. Thank you, dear participants. Your valuable, sir. Greetings from the Narsimha Reddy Engineering College, Autonomous Hyderabad, School of Computer Science. Sir. We are pleased to highly appreciate your presentation and elaboration as a resource person for workshop on emerging tools and techniques in cloud computing and data science, organized by the School of Computer Science. We would like to convey our sincere thanks, grateful for your fruitful session on data analytics using R. Your session is enriched participants of the FDP with knowledge and created an intellectual environment, sir. We will feel honored to collaborate with you in future also, sir. Thank you very much, sir, for valuable your time, and you have taken a good session, interaction session, sir. Thank you very much, sir.
Thank you, sir. Thanks for giving the opportunity.
Yeah,
participants, wish you all the best. Thank you.
Yeah, thank you, sir.
Sir, I have a meeting. I'm closing the session.
Yeah. Thank you very much, sir. Thank you, sir. Participants, any queries, please post the chat box. Otherwise, I will stop the class.